Today we're going to be discussing some multiplication properties of exponents. We know that the algebraic expression 2 to the third power times 2 to the second power can be written as this right here, where we have 2 to the third as our yellow 2's, and our 2 squared is represented by our 2 green 2's. Now, if we had this expression, 2 times 2 times 2 times 2 times 2, we could also simplify that down to writing 2 to the fifth power. Now today we're going to be talking about some shortcuts from how to get from this first point here and jump down to a simplified version. And the rule is that as long as we have the same base, we can add exponents to simplify the expression. So if I came back up here to the top, since we are multiplying these two bases together, I could have just said 3 plus 2 is 5 and skipped this middle step right here. So let's look at a couple of examples. The A example, I have 4 to the third power times 4 squared. Since our bases are the same, I can add my exponents together. The base will remain 4, but my new exponent will become 5. So this product has simplified into 4 to the fifth power, and 4 to the fifth power evaluated is 1024. In our B example, I can do the same thing because all of the bases are 2's, so we are adding up our exponents. So our base will remain 2, and I have 5 plus negative 2 plus 3. 5 plus negative 2 is 3, and 3 plus 3 is 6. Now I have to use a calculator, and I'm going to evaluate the 6th power. And 2 to the 6th power is 64. Next, we have 5 to the negative 4th times 5 to the positive 4. Since the bases are the same, we can use the shortcut rule. Negative 4 plus 4 is 0. And so 5 to the 0 power is 1. If you'll notice with the B and the C examples, we can have negative exponents with this shortcut, and instead of evaluating them like we did in our last video, where we turned it into a fraction, we can go ahead and use our shortcut rule and get the sum before we have to worry about moving things below into a denominator. The same rules that we have for example 1 apply to variables in algebraic expressions like we have in example 2. So let's take a look at A. I have x squared times x to the third times x to the first power. So if there's nothing there, we know that it's a power of 1. And just like before, since all of my bases are the same, we're able to use the shortcut rule by adding exponents. 2 plus 3 is 5. 5 plus 1 is 6. X to the 6th is as simplified as we can get it. For our B example, this time I have something a little bit different. I have bases of 2, n, and 3. This negative 5 is only applied to the n, and this 9 is only applied to this n. The 2 and the 3 both have exponents of 1, and since 2 and 3 are different bases, we're just going to have to evaluate those alone by themselves without using the shortcut rule. So we're going to have 2 times 3 times n to the negative 5 plus 9 power. So the 2 times 3 will turn into 6, and n to the negative 5 plus 9 becomes n to the 4th power. Since n is the only one with an exponent greater than 1, we don't have to worry about simplifying this further. 6 has an exponent of 1, and so 6 n to the 4th is the answer for the B part of example 2. Now that happens when we multiply bases, but if we ever have to raise a power to another power, meaning we have multiple exponents involved in the same term, we're going to have to do something a little bit different. When we raise a power to a power, we have a different rule. And instead of adding the exponents like we did in our first two examples, this time we're going to be multiplying them. So as you can see, 2 squared raised to the third power is the same thing as writing 2 squared times 2 squared times 2 squared. And that is the same thing as 2 to the 6th. So what we can do to bypass this middle step is just to take our two exponents, our 2 and our 3, and just multiply them together. 2 times 3 is 6. So we were able to cut out this middle step here. Let's look at example 3a. Here I have x to the third raised to the fourth power. I have two exponents here. Since it's a power raised to a power, that means I'm multiplying them. 3 times 4 is 12. For our B example, before I worry about multiplying my bases, we're following order of operations. And if you'll remember the mnemonic PEMDAS, we have to do exponents first. So before I multiply c to the fourth times c to the negative 2, I'm going to have to take care of raising a power to a power first. So I'll leave my c to the fourth alone, and instead I'm going to evaluate that second c. C to the negative 2 raised to the fifth power turns into c to the negative 10. Now I can evaluate this because we're multiplying the same bases, c and c. So that means that we have to add 4 to negative 10, and 4 plus negative 10 is negative 6. Now in the last video we said that you're not allowed to have exponents as negative for your simplified answer, so we're going to change this into a fraction. And c to the negative 6th becomes c to the 6th when it's in the denominator. So we have 1 over c to the 6th. For example 3c, I have an exponent here that's applied to this entire set of parentheses. So really, in effect, what I have is raising 2 to the third power as well as the x, because that 3 is going to apply to everything inside this parentheses. So we're raising 2 to the third power and x to the fourth to the third power. 2 to the third power is 8, and x to the fourth raised to the third power. We're raising powers to powers. That means that we multiply. So this becomes x to the 12th power. For our D example, it looks a little complex, but we're just going to follow the order of operations rules. Let's look at our first x here. We're raising a power to a power. That means we multiply. So that's going to become x to the negative 10. For our next one, everything inside the second set of parentheses is raised to the fourth power. So I have 3 to the fourth power. X to the fourth power will be x to the fourth. And here I have a power to a power. So we multiply. 2 times 4 is 8. Now there's no more exponents to be raised to, and we're combining our bases here. I do have similar bases. I have x's right here, so we'll have to combine those using the first exponent rule that we learned about. 3 to the fourth power is 81. X to the negative 10 times x to the fourth. We add those together, and it's negative 6. And y doesn't get combined with anything because he's by himself. Now x has a negative exponent, so we're going to have to change that into a fraction. 81 and y both have positive exponents. 81 with a positive 1 and y with a positive 8. That means that x is the only one that travels below, and when it does, its exponent turns positive. So our final answer will be 81 y to the 8th over x to the 6th.